Synaptic transmission!
So what is it?
Synaptic transmission is the biological process by which one neuron can communicate with another across a synapse.
Let's look at how this works. As we can see here, we have the axon with its myelinated sheath and the presynaptic cell, the synaptic cleft, and the postsynaptic cell.
Oh look, an action potential.
What's an action potential?
An action potential is an electrical signal sending information through your neurons. It's how your body communicates and does things. Step 2.
And now we have the voltage-gated calcium channels. The voltage-gated calcium channels now open and allow calcium to diffuse into the cell.
Calcium binds to the synaptic vesicle that has transmitter molecules packaged inside.
Now we see calcium bind to the vesicle, which is going to move down to bind to the presynaptic membrane via exocytosis. Now you'll see the neurotransmitters being dumped into the synaptic cleft.
What's exocytosis?
Exocytosis, a process of moving materials from within a cell to the exterior of a cell.
Oh, so it's like when a baseball bat binds with a piñata and releases candy, right?
Right!
Neurotransmitters in the cleft bind to postsynaptic receptors, opening them and letting sodium into the cell.
Sodium will cause an EPSP. Here we go.
EPSP? What?
An excitatory postsynaptic potential when sodium enters a cell, making an action potential more likely to occur.
What if it's not sodium?
An IPSP. An IPSP is an inhibitory postsynaptic potential where chloride enters a cell, making an action potential less likely to occur.
It's like when you make your mom happy, and she's more likely to give you a present. An IPSP is like when you make your mom angry, and she's more likely to not give you a present. But what happens to the extra neurotransmitters?
I'm glad you asked. There's 3 options. Number 1. Here we can see enzymes breaking down non-binding neurotransmitters.
Number 2. Transporters remove neurotransmitters for reuptake and recycling, forming new vesicles.
Number 3. Here we have neurotransmitters bind to the autoreceptors, sending negative feedback signals to the cell.
But what is a negative feedback signal?
Negative feedback signal is a message sent back into a cell to stop or pause a release of neurotransmitters.
You're right, Nala. Let's review.
The action potential travels down the myelinated axon as step 1.
Step 2. Voltage-gated calcium channels open. Calcium diffuses into the cell.
Step 3. Calcium binds to the synaptic vesicle, and then the vesicle travels down to bind to the presynaptic membrane via exocytosis, allowing neurotransmitters to release into the synaptic cleft.
Number 4. Transmitters in the cleft bind to the postsynaptic receptors, opening them and letting sodium into the cell.
Step 5. Due to the diffusion of sodium into the cell, an EPSP occurs.
6a. Enzymes break down non-binding neurotransmitters.
6b. Transporters remove neurotransmitters for reuptake and recycling, forming new vesicles.
6c. Neurotransmitters bind to autoreceptors, sending a negative feedback signal to the cell. So why is this important?
Our bodies do this every day. It's the key to understanding how our nervous system works. Without it, our cells cannot communicate. Without it, we may as well be dead.
Like this guy. His body had the wrong kind of electrical signal. Project by
Katie, Kira,
Lizzie.